All right. The skill is 6th grade, geometry, first standard. Generally, standard 1 in 6th grade of geometry talks about area of polygons. Complex figures are a form of polygons, but there's several polygons meshed into one figure that looks something like this. Some vocabulary you need to touch base with. Remember to use math is fun to define vocabulary words. A regular polygon and complex figure. They're very synonymous. They basically describe the same kind of figure, but two different terms. When we talk about finding the area of a complex figure, this is kind of what a complex figure look like. Now, they can look many ways, but this kind of is a good start. To find the area of complex figures, step 1 tells me to break the figure into multiple familiar shapes. If I look at this god-awful shape, I ought to be able to break it down into multiple familiar shapes. Right off the bat, I look right here and here. I'm able to take this one complex figure or irregular polygon and break it into 3 two-dimensional shapes. Well, what kind of shapes did I create? Well, it looks like I have 2 squares, and I know they're squares and not rectangle because when I look at the length and the width, they're the same. That describes a square, okay? And I know I got a big rectangle. Well, when I break this image down, the dimensions of certain things changes. When this figure was like this whole side measured 20. But when I broke it down, this piece got smaller. This one whole piece got separated into 3 pieces. Do you agree? Yes. You should. If I look at just this piece right here, what is it congruent to? Up here. So that means just this little piece is 10 feet. Okay? Well, and this needs to be 5. Change this to 5. Just so my example will play out the way I want it to. Change this to 5. Okay? Well, if this is 10 and all of it is 20, I've got to split the remaining 10 between 2 sides. So that means this side has to be 5 and this side has to be 5. And when I do 5 plus 10 plus 5, I get a whole side of 20. Does that make sense? It should. Here I can just find the individual area once I've segmented the shape. Area equals 5 times 5. Area equals 25 feet squared. I know those squares are congruent, so it'll be the same process here. 25 feet squared. And now I know my dimensions here. I know length times width. I know my length is 10. But I haven't found my width yet. My width is this side. Well, if I piece this side and this side together, it'll make this whole side. Do you agree? Let me show you what I mean. If I draw a dotted line. How do I know what the measure of just this little piece is? I've got to look across the street. Well, if this side is 5, then this little piece will probably be 5 as well. To find the width of this rectangle, I need the complete side. Well, the complete side is congruent to this complete side. So if I do 5 plus 5, I know that my width is 10 too. So my area has to be 100 feet squared inside the small rectangle. So I'm looking at 25 feet squared, 25 feet squared, and 100 feet squared. Well, Mr. Gray, what do I do from there? I add them, and I get 150 feet squared. And after you do that, step 3 is add the areas. Remember, don't just express your answer as a constant. Use the unit of measurement and the appropriate exponent. Hopefully this helped you. 3 simple steps. Now, you will run into some complex figures that require you to dig a little deeper. Just use your knowledge of the basics to dig deeper. Hopefully this helped.